Hi everyone. In today's video, we are going to clearly understand Wade's rule and the classification of Borane clusters into Closo, Nido and Arachno types. Many students try to memorize n plus 1, n plus 2, n plus 3, but they don't actually understand what these numbers mean. After this video, you will be able to classify any Borane cluster and you can count skeletal electron pairs correctly, and also importantly you can solve CSIR NET questions also. Let's begin from the basics. First we'll see what are borons. Borons are compounds of boron and hydrogen. Unlike normal compounds, borons are electron deficient. Boron has 3 valence electrons, so it cannot form enough normal 2 center 2 electron bonds. Because of this, borons form multi-center bonds like 3 center 2 electron bonds. Instead of simple structures, they form polyhedral cage-like structures. These cage structures are called clusters. Here example given as B2H6, B5H9, B6H6 2-, and even larger clusters like decaborane, that is B10H14. To understand their shapes, we use Wade's rule. Now we'll see what is a cluster. A cluster is a polyhedral arrangement of atoms. Here, vertices is boron or carbon atoms. Edges will be BB bonding framework. Hydrogens are either terminal 1BH and bridging BHB. Here importantly, Wade's rule deals with skeletal bonding electrons only, inside cage bonding, not BH terminal bonds. Now we'll see why do we need Wade's rule. Wade's rule helps us to predict the type of cluster based on the number of skeletal electron pairs. Important point is we only count electrons involved in cage bonding. We do not count electrons in normal terminal BH bonds. So we need a method to predict shape, type of cluster, electron requirement. That method is Wade's rule. Now we'll see the main concept of Wade's rule. For a cluster having n skeletal atoms, we'll see the cluster type skeletal electron pairs. Closo requires n plus 1 skeletal electron pairs and Nido cluster requires n plus 2 skeletal electron pairs. Arachno cluster requires n plus 3 electron pairs. So now let's understand what this word means. Here skeletal electron phase is equal to electrons involved in cage bonding divided by 2. Actually this table is very important. If you know this table you can solve these examples very easily. Now let's see what is Closo. Closo means closed. It is a complete polyhedral cage. All vertices are present. Example B6H6 2-. Electron pairs is equal to n plus 1 and it forms an octahedral structures. Example octahedron. And what is Nido? Nido means nest. It is derived from a closed structure by removing one vertex. So it is a slightly open. Example B5H9 and electron phase will be is equal to n plus 2. And last one we'll see what is Arachno. Arachno means spider web like. It is derived from Closo by removing two vertices. It is more open. Example B4H10 and electron phase is equal to n plus 3. As the structure becomes more open, it needs more skeletal electron pairs for stability. That is why Closo is n plus 1, Nido is n plus 2 and Arachno is n plus 3. Now we'll see how to apply Wade's rule step by step method. In step 1, we have to count total valence electrons. Boron has 3 electrons and carbon has 4 electrons. hydrogen is equal to 1 electron and it add if charge is present. In step 2, we have to subtract electrons used in terminal BH bonds. Each terminal BH bond uses 2 electrons. In step 3, remaining electrons is equal to skeletal electrons divided by 2. So that is skeletal electron pairs. In step 4, compare with table. You already see the table. If it is equals to n plus 1, that is Closo. If it is equal to n plus 2, that is Nido. And if it is n plus 3, that is Arachno. Now let's solve one example carefully. That example is B6H6 2-. In step 1, we have to count total valence electrons. Boron has 3 electrons. Here totally 6 boron atoms present. So 6 into 3 is equal to 18. And hydrogen has 1 electrons. Here 6 hydrogen atoms given. So 6 into 1 is equal to 6. And charge is given as plus 2. So charge adds 2 electrons. Totally 18 plus 6 plus 2 is equal to 26 electrons. Let's see the step 2. Subtract electrons used in terminal BH bonds. Here 6 BH bonds use 12 electrons. So 26 minus 12 is equal to remaining electrons 14. In step 3, divide by 2. 14 divided by 2 is equal to 7 skeletal electron pairs. Here n is equal to 6, so n plus 1 is equal to 7. So this is a Closo cluster. Now let's see one more example. B5H9. Here total valence electrons we have to count. Boron, here totally 5 boron atoms present. So 5 into 3 is equal to 15 and 9 hydrogen atoms present. So 9 into 1 is equal to 9. So 15 plus 9 is equal to total valence electrons 24. In step 2, you have to subtract terminal BH bonds. So 5 BH bonds uses 10 electrons. So 15 minus 5 is equal to 10 electrons. Remaining how much? 24 minus 10 is equal to 14. 14 divided by 2 is equal to 7. So skeletal pairs is equal to 7. Here n is equal to 5. So n plus 2 is equal to 7. And this is a Nido cluster. For more examples, I will make one more video using previous year CSIR NET questions. Now let's see the reaction. This is very important for CSIR. Decaborane reacts with acetylene. 2 carbon atoms enter the cage. Now total skeletal atoms becomes 10 boron plus 2 carbon is equal to 12 vertices. For Closo, n plus 1 is equal to 13 electron pairs required. The product formed is C2B10H12. This compound is called O-carborane and it is a 12 vertex Closo cluster. And this is very important for CSIR. In December 2018, CSIR NET, based on this concept, they have asked one question. Now, we'll see the shortcut formula. For boranes, in general formula BnHn, we'll see the Closo. For Closo, having general formula BnHn2-. And for Nido, BnHn plus 4. And for Arachno, BnHn plus 6. Let's summarize. As the cluster becomes more open, Closo will be compact, Nido will slightly open and Arachno will be more open. So electron requirement increases n plus 1, n plus 2, n plus 3 because open structure need more electrons for stability. For n skeletal atoms, Closo will be n plus 1, Nido will be n plus 2, and Arachno will be n plus 3. More open structure is more skeletal electron pairs required. If you understand this logic, cluster chemistry becomes very easy. If this explanation helped you to if this explanation helped you to understand Wade's rule clearly, comment below. In the next video, we can solve advanced CSIR cluster problems. Thank you for watching. Have a good day.